Once we were confident in our designs, it was time to get the circuit board printed. So to print a circuit board, we had to take all of our drawings and put them in a program that allows us to route the electrical connections, organize the layout of all of our components, and that type of thing, so we could fit all the electronics in a smaller package known as a printed circuit board. We used a program called Eagle, and part one of the process is creating a schematic capture, which is basically putting down all the components you want to use and connecting them correctly. The same way we had them wired up in the lab is the same way they should be connected in the schematic. And you can see we had a lot of stuff, so we were trying to keep it organized, and we labeled the section by functionality. So we had, for example, the regulators, the LEDs, the peripheral connections, which are things that were on the front panel, so where all the buttons and switches where their wires would go, the temperature sensors, and all the other things we were planning to implement. The second part of the process is the layout. And layout is where you decide where things will live physically on the board. And you have to make sure that components aren't too close to each other, that you have the right size traces to carry the current, which I'll show later in the video. But there's a lot to consider in layout. It's also important to think about where the board will go and what things should be closer to the edge of the board, what things can be in the middle of the board, and decisions like that. We were lucky enough to have a PCB printer on campus, so we were able to go there and send our design off to like an actual PCB professional printer to be made. So we took all of our files from the software to the lab, and the first thing you do is upload your design, and you can see the layout, which is the same thing that we did in the program. You can see it on the screen on this device. And you can also see me on the side getting ready to put my copper plate in. There are two stations. There's the drill station and the laser station. In the corner, you can see what the machine is doing on the screen there. And it's drilling a hole that's strictly to help the machine locate where it's looking on the board. And the software shows you the drill view. The drill station is first, and it reads in our files and it finds where we need holes and what size holes we need, and you can see it drilling the holes in the copper and switching out the drill bit when it needs a different size. We'll need holes to put in the different components that we want on the board. There's also another process that will be somewhere in the middle of the laser and the drill, and that's called electroplating, but we didn't have to do that process for this particular design. Once the machine is finished drilling all the holes, you remove it, and you can see all the holes that it drilled, and you placed it in the laser machine. The laser machine also has all of our design files, and it can see how we routed all of the connections between the different components. And the laser machine etches away the copper that we don't need, so it can create the traces between the different components. You can see the laser going, and the software shows you the laser view of what's happening. So that's what it looks like when you take it out of the laser, and then it goes back into the drill again, so the machine can separate our PCB from the rest of the copper, and that copper can be reused for something else. And voila, we have a PCB. And these are what I mean by traces. These lines that connect the different components, or in this case just the different holes where the components will be. You can see we have some bigger, which means they need to carry more current. So I think these were where our power, maybe the MOSFETs were. And then these smaller traces were for the other components that didn't need that much current.